Problem 3-4. A particle of mass m slides down a fixed frictionless sphere of radius r, starting from rest at the top. In terms of m, g, r, and theta, determine each of the following for the particle while it is sliding on the sphere. 1. The kinetic energy of the particle. So in this case, energy is conserved as the particle slides down, or as this mass slides down the sphere. So k plus u equals 0, equals a constant, any constant we like. It's just going to be c in this case. And u equals mgh, but in this case, because we're using the height of the sphere, it's going to be mgr. So then we get u plus, so at this point when the mass is at the top, the kinetic energy is going to be 0 because it's 0, because it's not moving, so the velocity is 0, but the potential energy is going to be mgr. So you have 0 for the kinetic energy plus mgr equals, and then the final kinetic energy would be k, that's what we do not know, plus mgr, and then we have to take the vertical component because we need the height as the sphere is progressing to the side, so that's going to be cosine theta, with this being theta and taking the angle, so we get the vertical component, cosine theta, and then we're solving for k, so you subtract it to that side and you get mgr minus mgr cosine theta equals k, and then you factor out the mgr, so you get mgr 1 minus cosine theta equals k. And that is your answer to part 1 of A. Then part 2 of A. You need to find the centripetal acceleration of the mass. So we know the equation for centripetal acceleration is v squared over r. So in this case, r is as it's written, and then we know that the kinetic energy of the object is, kinetic energy of the object, since energy is conserved, final minus initial. So we have 1/2 mv squared equals mgr 1 minus cosine theta. And then so we want to find v squared over r. So we're going to times this, so we're going to isolate the v squared over r. We're going to divide by r, and the m's cancel out, and this side gets times by 2. So then we have v squared over r, which equals centripetal acceleration, equals 2 g 1 minus cosine theta. And that is your centripetal acceleration and the answer to part 2. Now, for part 3, we're asking for the tangential acceleration of the mass. And the only force with a tangential component, which is a component that is tangent to the circle, is the gravitational force mg, which is that. And so, as the diagram shows, this diagram that I'm about to draw, alright, so you have this, and then you have your block. And you have the normal force coming out of the block, which is perpendicular to the surface of the sphere, and then you have this, and this, and that would be your mg right here because it's going straight down, and then you have your mg sine theta, and then, alright, so this is the tangential component of your weight, mg, so you have mg sine theta, the only tangential component. So by Newton's second law, ma tangential equals mg sine theta, so at equals g sine theta. Woohoo! Alright, where is my eraser? I need my eraser. Alright, on to part B, and I've run out of room, so actually I'm just going to write it down there. Okay, so part B. Okay, so now we need to determine the value of theta at which the particle leaves the sphere. So it leaves the sphere when the normal force, which is this force coming off of the block, is close to 0. So at that point, the radial component of the weight provides this centripetal acceleration. So we have mg cosine theta equals ma centripetal acceleration. Therefore, g cosine theta equals ac, because that is the centripetal acceleration. And then that, as we figured out in this part 2, centripetal acceleration equals 2g 1 minus cosine theta. So we got 2g 1 minus cosine theta. And then in cosine theta, and therefore we have cosine theta equal to 2/3, and then theta equals cosine inverse of 2/3. Woohoo! Done.